Hi guys. So today we're going to take a look at question 4 of the 2016 exam paper 2. Okay, so we have a diagram showing a semicircle standing on a diameter AC, BD perpendicular to AC, and we want to prove that the triangles ABD and DBC are similar. Okay, so first of all, what does it mean for triangles to be similar? So triangles are similar if they have equal angles. If they have equal angles. Okay, so, well, let's just illustrate these angles here. So we're going to call this angle 1, this angle 2, this angle 3, this angle 4, this angle 5, and this angle 6. So we want to show that, these match up in some way. So maybe 1 equals 4, 2 equals 5, 3 equals 6. Something like that. Something where the three angles are equal to, at least, they're equal to one of the angles in the other triangle. Okay, so how might we go about this? Well, are there any that we can show right off the bat that they're equal? Well, we've got two right angles, so we've got two right angles here, since this is a perpendicular line. So straight away we know that angle 2 equals angle 5. Okay, so that's 1. And now we're left with angle 1, 3, 4, and 6. And so we want to know, well, what do we know about, the relationship between these angles? Okay, well, first of all, we know there is 180 degrees in a triangle. And so we can say that angle 1 plus angle 3 is equal to 90, because the other angle, angle 2, is a right angle. So angle 1 plus angle 3 is 90, and similarly, in the same way, angle 4 plus angle 6 is also 90 degrees. Okay, that doesn't seem to be enough information though. So, well, what other information do we have? Well, we know that we're working with a semicircle, and they generally don't tend to give you information for no reason. So what information might that be giving us? Well, we know that in a semicircle, any angle that is made, so for example, this angle, ADC, makes a 90 degrees. So we have a 90-degree angle here. So we can, and since that right angle is angle 3 plus angle 4, we know that angle 3 plus angle 4 equals 90. So that's a corollary, I believe, of one of the theorems. I'm not sure which one it is. It's the circle theorem. Angles in a semicircle are always 90. So what that means is, so like if we drew this angle here and then we connected this to C, this would be a right angle. So any one that you create would give you a right angle, namely the one that they've given us. So now we know that angle 3 plus angle 4 is 90. And now we have these three equations. So let's try and combine them. So if we consider the first and the third equation, consider 1 and 3, well then angle 1 plus angle 3 is 90, and angle 3 plus angle 4 is 90. And so angle 3 plus an angle equals 90, and angle 3 plus an angle equals 90. So angle 1 has to be equal to angle 4. Okay, so, well, that's one thing we were trying to show. And then if we consider equation 2 and equation 3, then we have angle 4 plus angle 6 equals 90, and angle 3 plus angle 4 equals 90. So in the same way, angle 6 must be equal to angle 3. And so now we've shown angle 1 equals angle 4, angle 2 equals angle 3, and angle 3 equals angle 6. So our angles are equal. So ABD and DBC are similar. Okay, now on to part 2. So if the length of AB is x, the length of BC is 1, and the length of BD is y, write y in terms of x. Okay, so I've added in this diagram here to make it easier to visualize. So the length of AB is x, the length of BC is 1, and the length of BD is y. So we want to write y in terms of x. Well, what information do we have? So, well, we know that these triangles ADB and DBC are similar, and we know that for similar triangles, their sides are in proportion. Their sides are in proportion. And well, what do we mean by this? So we showed that this angle was equal to this angle. This angle was equal to this angle. And of course, these two right angles were equal. Okay, and so the sides opposite the equal angles are in proportion. So the side opposite the blues, so AB over BD, is equal to the proportion of the sides opposite the reds, which is BD over BC, and this is equal to the proportion of the sides opposite the purple. So this is AD, and this is all in lengths. Let me just stipulate that. AD over DC. Okay, so that's what this means. Okay, so now can we fill any of this in? Well, we know that AB is X and BD is Y, and this equals BD, which is Y, over BC, which is 1. Well, we don't actually even need AD and DC, which is great because we didn't know anything about them anyway. But now we can express X in terms of Y. So if we multiply both sides by Y, we get X equals Y squared. And we want to write Y in terms of X, not X in terms of Y. So if we take the square root of both sides, we'll get Y equals the square root of X. And we don't have to worry about their plus or minuses when we take the square root, because we're just talking about length. So we know that everything is positive here. So we just know now that Y is equal to the square root of X. Whatever X is, Y is the square root of it.